Right, so in the last exercise, we looked at exceptions and assertions for the first time, but we were using kind of a contrived example of testing for even numbers. So in this exercise, we're going back to the rainfall application where we were processing a text file and a user was entering in years and months to find out, what the average rainfall in a particular month was, or the rainfall of a particular month in a particular year was. And we sort of um, the code that we wrote for exercise 21 was good, but it probably ignored a lot of potential pitfalls. Things like, what if the user types in an invalid year, an invalid month, and what if the file didn't exist in the first place? And what we'll see is that, we kind of examine, well, what happens if that happens? What happens if that occurs? And what does the user actually end up seeing? And then let's use exceptions sort of extensively to make this happen. After we get done doing that, I also want to modify the program to handle handle the input of months a little bit better and allow users to type in the months in either numbers or string form, and that'll help us kind of get a little bit more sense about how to create functions that parse input and generate exceptions if it can't determine what the correct value might be. Okay, so before I even start to mess with the code, I want to run the program, and let's deal with the issue of years first. So, oops, I gotta save that. Let's type in 2016. So that's clearly a value that's not there. Month is 2, and what do we get? Well, we get what's called a key error. Right? And the key error is generated on line 39. So if I scroll down here, line 39 is accessing my table. Remember the table data structure? It's a dictionary whose keys are years. And it's a kind of a predictable answer. There's a key error, and 2016 doesn't exist in the table. All right, so there's a number of ways to fix this problem. The one is, of course, to validate the year, right? So the user might be asked to, we could determine that it's not between first and last year. But because we're trying to demonstrate a little bit about exceptions, I'm going to let this exception actually happen. And the difference now is that I'm going to catch it. So I'm going to take this entire block and I'm going to encapsulate it in a try except. And it's a key error. So whenever I get a key error, that must mean that I'm accessing a year that doesn't exist. And I'll say, sorry, you've asked for a year that does not exist. All right, so now let's try this again. 2016, April, boom. I'm sorry you've asked for a year that does not exist. Now I want to talk about the placement of this try block. If I had placed instead the try block outside the while loop, the problem with this is that once the user threw that exception, if you notice over here, I can go again, right? I can type in 2014 March and it works. But if I change this code and I run it now, I'll still get the exception and I'll still catch it. But notice now my program's done, right? So it was not by a fluke that I put that try block inside the while loop, right? If the try block is outside here, well then when I throw that exception in this line of code, I'm jumping all the way out of the while loop. So by putting the try block in here, when I throw that exception on this line, I catch it and I return back up to the top of the loop. All right, the second one that we wanted to look at was allowing the user to type in a month and detecting that that's not the correct value. Instead of going right to that, though, I want to think about, well, how do we allow the user to type in not just integers, but also strings? And I'll deal with the whole exception handling from that end. So I'm going to change this. So we have a function it's called resolve month. or even maybe like get month. Right? And it's going to ask the user for value, and it's going to make a couple of checks to see whether or not it can resolve it as an int or use it as an actual string that the user might type in. Okay, so user input equals input. I'm not going to convert it to anything just yet. User input equals please enter month, 1 or January. Okay, so I'm kind of telling the user that these are the things that I'll accept. And this is what I'm going to call now, instead of this way. Now the user input is either going to be an integer or it's going to be a month string. So the first thing I'm going to do is I'm going to try to parse it. You might have seen this before when you ask the user to type in an int, and they don't actually type in an int, you get a value error. Right? And so that's an exception that we can handle now. I'm doing it in 2 steps. So I have user input as a string. I'm trying to parse this string. If they type in 1, this will work. If they type in January, of course, this is going to throw an error. So if it works, we'll just let that go for now. And if I get a value error, that means the int function was unable to parse this string, maybe it was January, into an integer. So at that point, I want to see, well, did the user type in a string that's one of these months, right? And I can access that month string. So if user input is in months, well, then we just return the index, right, where that was found. And for a list, and actually I'm going to have to change this to be a list, not a tuple. Doesn't support that index function, but we can do user input. All right, and so that'll return the index where that user input was found. And so for January, it'll actually return 0, which is kind of nice because that's what I'm using later on, the rest of the code. And in fact, at this point now I can go down here and start using directly month. Okay, now what if it wasn't? All right, so if it wasn't in the months list, now I've got a real problem, right? Now the month is invalid, and I'm going to raise an error. Now I don't want to raise a key error. I want to raise a value error. It's an incorrect value. So user input is not a valid month or string number. If I get past this, right? So I can do this out here, I could do this over here. The only way I'm ending up on this line is if this succeeded, and that's it, right? That's the only circumstance, right? Because if I get into the except block, I'm either going to return or I'm going to raise another exception. So I can start down here, I can start over here. I'll go up here. So if m is less than 1 or m is greater than 12, then the user's typed in an integer, but it's a bad integer, right? And if that's the case, I'm going to raise another error. Raise value error, user input. And in fact, I can actually build this string as a variable so I don't have to repeat it. And I can just do this. Same error, right? But different circumstance. Otherwise, I'll return m minus 1. Right? I want to return, if the user types in 1, I want to return 0. So at this point, I've got a function that accepts the user input and it does all sorts of checks, right? It's going to detect whether or not it's a string version of a month, whether it's a numeric value, whether it's a legal numeric value. And the bottom line is that this is either going to return the correct number, 0 through 11, or it's going to throw a value error with a particular message. So let's test that. Oops, looks like got confused with my languages again, and almost every other language I use, this is an OR. Python, it's like that. Okay, so 19, I'll put in a valid year, but let's put in like a ridiculous month. Okay. All right, value error, 90 is not a valid month string. Good. Let's run it again, 1996 or 3, whatever. And let's enter in a string now. You know, any month, right? Any month is not a valid month or string. Good. Let's type in 1996 and 4, and that should work. Good. 1999 and March works as well. Okay, so we can see that the inputs for these months work. Now I was getting all these traceback errors and value error. Should be obvious to you what I'm going to really want to do here is I want to catch that value error and actually display a much nicer result. I also want to put some room for the prompt there. So down here I already caught a key error, but the month function might be throwing an error as well. So I'm going to put yet another except clause, and that under that circumstance I'd get a value error. So I've kind of picked that wisely in that, you know, I'm throwing a value error so I can differentiate it between throwing that key error. And we can say print I'm sorry, you've asked for a month that I cannot understand. Okay, and that'll print out that value. And in fact, this is kind of a generic message. Remember that we actually threw a nicely customized message of specifically what the user typed in. I can also print that out as well. And the way we do that is actually giving a name to the exception. So I don't need to do this, is not required, but if I want to refer to the actual exception object, I can say as E. So value error, I'm catching a value error and I'm going to call it E. And I can print that value, and that when I do print E, that'll print whatever the exception message was. So that'll be a little bit nicer, cleaner way to handle that. So 1996, any month, and now it says I'm sorry, you know, any month is not a valid month string or number. You've asked for a month that I cannot understand, but I can keep going, right? 90, same deal. That's going to be a key error because I misprinted it, mistyped it. But eventually I can type in valid input. Okay, so we've covered the use case where the year is wrong. We've covered the use case where we've got, first of all, a much more flexible way of entering in a month that's a lot nicer for us to work with. And we've also sort of much more gracefully handled any of this invalid user input in the bottom of this loop. But now let's deal with the point where that text file wasn't even found. So if I do an ls here, I've got New Jersey rainfall.txt. Rather than change the code, I'm just going to move New Jersey rainfall to test.txt. Okay, so now at this point I've renamed it, right? So I don't have New Jersey rainfall. Let's see what happens when I run my program. And of course I get an exception, right? File not found error. By the way, that's a pretty dead giveaway on how to catch the exception, right? How to handle it much better. So if I do up here, and it's load table that's really throwing this exception, right? Because it's in the open command in load table, right? And the exception trace is giving us a really nice indication of where that is. Line 12, right up here. I don't know what load table should return if we can't do it. I'll let the exception propagate. But over here, we'll put a try block. And we'll say, sorry, file name, which is what the file that we're actually asking for. And I'll exit, because I can't do anything. At that point, once I catch that exception, there's nothing I can further do if I don't have the text file. Okay. Oops, looks like I messed up my print statement again. File name was not found. Oh, I forgot. I didn't really do that. Let's do that. Let's say file name equals. Okay. Let's use file name. Since I'm using it twice now, I don't want it spread around my code. Let's do it that way. Okay, so now I get a nice output message. If I move test.text to New Jersey rainfall.text again and rename the program, all's well, and it works. Okay, so this is kind of a much more real-world example of handling errors that may be generated not by us. So for instance, the key error, it's generated when we access our dictionary with an invalid key. We could catch errors that we're actually raising, right? This is being used for control flow. We're actually purposely throwing these value errors with revised messages. And we can also handle some really unexpected events in a little bit nicer of a way.